Okay, so we're back here for part 2. And what I've done here, I've redrawn the original picture. We have the big right triangle. We draw the altitude. It creates 2 small right triangles. And what we just proved was that all 3 triangles are similar by angle-angle, similarity. Now, labeling, we have a leg, and then this whole thing here, that's the hypotenuse. We have the altitude. The other thing we're going to label is that when the altitude hits the hypotenuse, it breaks AB into 2 parts. I'm going to call these part and part. Now, they're not the same. We don't know that they're the same, so this is just a part, and this is a different part. Okay, so now there are 2 formulas that come out of this. The first one is if we compare the 2 small triangles. Compare 2 small triangles. And in this case, we will say triangle ACD, and that was similar to triangle CBD. Okay, that's what we proved. We proved that those 2 had to be similar by angle-angle. Okay, so if they are similar, then that means that the corresponding sides are proportional. So we're going to make a proportion here. And let's go ahead and say, we'll start with AD. Okay, here's my 2 fraction bars for my ratios. AD, the ratio of AD, and that matches to CD, equals, now I'm going to use CD again, but this time it's in this triangle, and that matches to BD. Now if you look at that, that should look somewhat familiar to you because back on the front, we talked about what was called a geometric mean, where x, this was the same value, was in between these 2 values, and these had to be the same. Well, what happens here, because we have similar triangles, we have created a geometric mean. Now, if we cross multiply, we get CD times itself. I'm going to write CD squared equals AD times BD. Now that's the first formula. You might look at that and say, I don't know how I'm going to remember that. Well, there's an easier way. Notice that we labeled CD, that is the altitude. So I'm going to say altitude squared equals AD times BD. AD is a part and BD is a part. Altitude squared equals part times part. That is our first formula. Okay, so there's number 1, formula number 1. And it comes from the geometric mean, which comes from similar triangles. Okay, now let's compare one big triangle, or the big triangle, to one of the small ones. So the big one, okay, if you look at the top here, we had triangle ABC, that was the big one. And let's go ahead and we will compare that to triangle ACD. That's fine. Triangle ABC, triangle ACD. Triangle ABC is similar to triangle ACD. Okay, so now let's make another proportion. Well, let's go with AB. Now that matches to AC, those correspond. In the big triangle, we also have AC, and in the small triangle, that matches to AD. Again, notice that these are the same value. It's the same length. That is another geometric mean. So AC squared, AC times itself, equals, and I'm going to write the AD first, this length times the length of AB. Remember, these are just segment lengths. These are going to be numbers. Now, how are we going to remember that? Well, AC is a leg. So leg squared equals. Now, AD is a part, but it's the part that is next to AC, or what we say adjacent. That is the adjacent part. I'm going to write that ADJ part times AB. Well, AB is the whole hypotenuse. It's the adjacent part times the whole hypotenuse. And that is formula number 2. So we've got formula number 1, altitude squared equals part times part. It's the product of these two parts. Product is multiply. The leg squared, the length of this leg is equal to the part next to it, the adjacent part, times the whole hypotenuse. Now, if we had done the length of CB, if we use this leg, then this becomes the adjacent part. So it depends which leg you're using. Okay, now let's do a couple examples here to kind of show how are we going to use these formulas. So example, and we're actually up to example number 2 here. So let's say we have, here's the picture. And we'll say here's 5, 20, x, y, z. And we want to find x, y, and z. Now you have to understand, you can only use these formulas if a geometric mean exists. And the only time that's going to happen is if you have a big right triangle and you drop an altitude, if you draw an altitude from that right angle, because that creates the 3 right triangles. Now the easier formula here is to do altitude squared equals part times part. So if we look at, in this case, let's find x. That's our altitude. Here are the legs, right here. And then the 5 and the 20 are the 2 parts. Okay, so for this example, I'm going to write down the formula. Altitude squared is part times part. The altitude is x, so x squared equals part 5 times the other part 20. And now we solve. 5 times 20 is 100. To solve that, you take the square root of both sides, and you get x is equal to 10. Okay, so that's not too bad. So we found that x is 10. At this point, you actually have some options. Because we now know the altitude, in this right triangle here, you could do a squared plus b squared equals c squared. You could use Pythagorean theorem. Now, I'm going to show you that I think it's actually easier to go with leg squared equals the adjacent part times, I'll just say the whole, times the whole hypotenuse. If my leg is y, okay, so y squared equals, the part that's next to y is 5 times, now what's the whole hypotenuse? Well, it's 5 plus 20, which is 25. That's segment addition postulate. 5 plus 20 is 25. So 5 times 25. Now, we know that to solve this, we're going to need to take the square root. You'll notice I didn't even multiply this yet. Well, it's because I look at this and I know this is y. 25 is perfect. So if I take the square root of this whole thing, since that's a perfect square, I can pull that out. The square root of 25 is 5, and what's left underneath is still this 5. So we get y is equal to 5 square root 5. That's a good answer. That is simplified. Okay, now, what if we want to find the z? Well, z squared equals, z is a leg, leg squared equals the adjacent part times the whole hypotenuse. So what's the part that's next to the z? This time it's 20. What's the whole hypotenuse? Well, that was 20 plus 5, which is 25. Now, again, you know you're going to be taking the square root of both sides. In this case, 25 is perfect. But the other thing I notice is that 20 will have a perfect square factor. It will have 4. I'm actually going to multiply these together and get 500. And when I look at that, z equals the square root of 500, but 100 is a perfect square factor. That's 100 times 5. What's the square root of 100? I can take the square root of that. That's 10. And what we get for our answer is 10 and we still have a 5 underneath, 10 square root 5. Okay, so there's the answers there. If you had wanted to do Pythagorean theorem, I could have said for z, I could have done 10 squared plus 20 squared equals z squared. And this would have been 100 plus 400 equals z squared. And that's 500 equals z squared. And then I go through and I do that. And, you know, that's fine. It would end up getting you the same answer. I personally prefer to use these two formulas to find it. All right, let's do another example. So here's number 3. Let's say the picture this time looks like this. And here's 12, here's 9, here is z, here's x, and here's y. Now this is a geometric mean because this is a right triangle, the big one, and it makes two small right triangles. So we can do altitude squared as part times part. But before I do that, let me label, here's the altitude, here are the legs, 9 is a part, y is a part, but we kind of have a problem here. Let's see, well, the whole thing would be 9 plus y, okay, or I'll say y plus 9, right there. How are we going to find this? If we do altitude squared as part times part, we would say x squared equals 9 times y. And the problem is we have two variables, we can't solve that. Okay, so can we try leg squared? Can we do leg squared? We do have a 12 here for a leg. So if we do, I'll write down leg squared equals the adjacent part times the whole hypotenuse. The leg is 12. 12 squared equals, the adjacent part is 9 times the whole thing. The whole thing is where I add these, and that's y plus 9. I'll put that in parentheses. So 12 squared, 144. We have to distribute. We get 9y plus 81. Now this is a normal equation. We're not going to square root. Let's go minus 81 to move it to the other side. That's 63 equals 9y. And then we divide by 9, and we get 7 is equal to y. Okay, so y is equal to 7. I'm going to put that in the picture. Now that's actually nice because 7 plus 9, the whole hypotenuse is 16, so that may help us out. Now we have enough that we can do altitude squared as part times part. Altitude squared, the parts are 9 and 7. Now you can multiply and say that's 63. I'm going to take the square root because I see that the square root of 9 is 3, which leaves us 7, which cannot be simplified. And so the answer is 3 square root 7, and that's a good answer. Now what do we need? Z. Z is a leg. Let's do leg squared equals the adjacent part. Now the part next to z is 7 times the whole thing. What's the whole hypotenuse? We found that to be 16. Again, you could multiply, but let's take the square root because 16 is perfect. I'm going to pull that out. That's 4 square root 7. And now the problem is done. You have options sometimes when you do this. You could have done x squared plus 9 squared equals 12 squared. A, B, C, Pythagorean theorem. You could have done that. Okay, so that would have found you x, and then you could have gone from there to figure out the rest of it. I decided to do it like this. All right, that is the end of part 2. We have one more part.